All right, lesson 14. The topic is multiplicity. So this is brand spanking new for everyone involved. So today's goal. I can use my knowledge of properties of polynomials to predict and sketch the graph of a polynomial or develop an approximate equation to model a graph polynomial. So basically what we're going to do is we're going to go through and I'm going to develop this through the lesson. Okay? I'm going to build your knowledge of properties of polynomials because you don't have any at this point, or not the ones we need. And then once I go through and show you that, I want you to be able to graph a polynomial and I want you to come up with an equation for a polynomial. So those are the two outcomes. The yellow is what I'm going to do for you. All right, so here we go. To understand multiplicity, so that's the topic today, we need to review and specify the properties of polynomial functions we're familiar with. So linear functions, giving yourself a quick sketch. Okay, Cartesian plane, x, y. What do we know about it? Well, there's a line. Okay, so graph is a line. Okay. What are the other key properties here? There can be up to one x-intercept. Up to one x-intercept. Intercept. All right. So right here. There doesn't have to be an x-intercept because if I draw a line parallel to the x-axis, then there'd be no x-intercept. So that's why I use the wording up to. Similarly, there can be up to one y-intercept. Same reason, except I could draw a line vertical. And the only other point, and you're going to think this sounds silly at this point in time, the last point I want to make is that crosses the x-axis as a line. And I'm stating the obvious again because I said the graph is a line and it crosses the x-axis as a line. And there's a reason for that, and you'll see it as we move on, okay? But at this point, just looking at how it crosses the x-axis, and that point here that I made right here is going to make a lot more sense when we get into the other functions. So flipping over, quadratic functions. So again, you can give yourself a sketch here. So if we keep with the trend that we had before, all right, what are the possible types of graphs? Well, we can have a parabola that looks like this. We can have a parabola that looks like this. Or we could have a parabola that looks like this. So there's a whole there's more options involved here. So if I go back and look at the properties, first one, graph is a line. This time you're going to say the graph is a parabola. All right. Matching up, because I want to keep the points consistent here, there can be up to one x-intercept. Well, how many x-intercepts can you have with a parabola, right, with a curve? We see that one I drew here, there's no x-intercepts. Here, there's one x-intercept. And this one has two x-intercepts. So the graph can have up to two x-intercepts. Is that true with the y-axis or the y-intercepts? No, absolutely not. If it's a function, we can only have one y-intercept. So I'm gonna write it in. It's not as important as it seemed off the start. Can have up to. Actually, for this one, I can put will. Oops. It's not a if, and, or maybe. It actually will have one y-intercept. All right. Keeping with the other one, the fourth point was crosses the x-axis as a line. Well, how would you describe how it crosses here in here, and that's if we zoom in. Actually, I can zoom in. If I make a box, there we go. So if you look at that, and it's a little bit blurry, but if that's all you could see in the window, if that's all that you're allowed to see, you would have to conclude that it crosses like a line, because it looks like that from that picture. So, if two intercepts, the graph crosses like a line. What happens if there's only one intercept? What happens if there's only one intercept? So let's zoom in here. So there, we can see that the x-intercept, if there's only one, it acts like a parabola. So if one intercept, the graph crosses like a parabola. And now there's one more point I want to add here, and we'll go back and talk about it. What do you notice about the graph itself? Okay, the graph itself. We look at a parabola where the arrows are pointing. With the quadratic, the graph enters and exits the graph in the same direction. So as I was saying, it enters and exits in the same direction. So the ends of the graph, enter and exit in the same direction. So now I'm going to go backwards, and we're going to add one more property to the linear one from above, because with it, no matter which one I did, okay, it enters and exits in opposite directions. So it came in from the bottom, exits the top. Okay? So graph enters and exits on opposite sides. Sides of x-axes. All right. So as we move along here, so that was quadratic. Now we're going to move to a cubic. And a cubic you've never seen before, so now I'm going to bring the graphing calculator in. Now, from your investigation, you're going to know some of this already, but I'm kind of assuming that you don't know everything. This is the general shape of a cubic. So that's our general shape. So I'm going to steal that picture, take a screenshot, black and white, come back here, paste that on. So here we go. So that's one possibility. So I guess I've been doing the graphs over in this corner. So you want to give yourself a quick sketch. So that's the general shape. Now, it could look like this. So I'm going to do this one in blue. Okay. And it could look like this, and I'll do this one in green. So just touches and then goes through. So here are the only possible situations. This graph has one x-intercept. This graph has two x-intercepts. And the original one I graphed ends up having, I guess I can circle them all at once, has three x-intercepts. But it has to have one intercept. I can't get away from that. So a couple of properties here then. And again, we'll try to match it up. Okay, I'm not going to worry about the first point anymore. Graph is a cubic. It must have between 1 and 3 x-intercepts. Okay, you can't have no x-intercepts. Why is that? Well, it goes back to the line here. If you look at all three graphs that I made, okay, they exit in opposite directions. All right, so that goes back to the fact that the graph enters and exits in opposite directions. So I'm now out of order with those properties, but it ties together a little bit better. I'm not going to worry about the y-intercepts anymore. And I want to talk about how it crosses. I want to talk about the base graph. So if I go back and I'm going to clear this graph, okay, whoops, clear. And I'm just going to put x cubed in. We graph it. And what I want to do is I want to zoom into the area at the origin where it crosses. So the window, I'm going to make it between -1 and 1. Oops, that didn't work. -1 and 1. -1 and 1. So we're looking really, really close at the origin here. See how it has that S curve, that S snake to it? So when it crosses that x-axis, it can cross the x-axis with an S pattern. Now all the other patterns can be found here. Okay? Here's our parabola. Okay? So yes, there's our parabola. There's our line. Okay? And if I zoom in, again, you can't tell me whether that's from a cubic, from a quadratic, or whatever. It looks like a line. Similarly, I don't know how this will look. If that's all you could see, you wouldn't know if it's a parabola or a cubic. So, that being said, the only unique thing here is this point right here, that the cubic can go through the x-axis with an S curve. So that is a possibility. So there is your properties for a cubic, or the key properties for the cubic. All right. Now we get into the quartic, and again, I'm going to bring up a quartic graph, and you've done this in the investigation, and this is where we start getting into some reruns. Okay, and here's our quartic, and again, you've seen it when you did the investigation. So take a screenshot. So this is kind of a standard quartic, and there are a couple of options with this, so if you want to make the axes a little bit bigger. So our quartic could be up here, doesn't have to cross. It could come up, and it could touch in two places. It could come up and touch, and then not touch. So now we have a whole bunch of options here. We have no x-intercepts. We have one x-intercept. We have two x-intercepts. I don't have the 3 drawn. And here we have 4 x-intercepts. So quartic can have 0 to 4 x-intercepts. Now, can we tell if it is, or why is that? Because the graph enters and exits in the same direction. Enters and exits in the same direction. Now, if I was to zoom in, does it bring a new shape to how it crosses the x-axis? So you're saying, well, the other one, you had to go back and just do a base graph. So let's quickly look at that. Let's clear this one. Let's go x to the 4th. All right, I'm going to change the window. So we're zoomed in to see what it does at the x-axis. 1, we hit graph. Now, if you were given this on a test and I said, tell me what type of function is it, you would have a very difficult time telling me the difference between this being a parabola, and that's what I would think most people would answer, but this is actually a quartic. So the shapes start to repeat themselves. Okay, so it does not provide a new shape, new, and I'll put that in quotes, when crossing the x-axis. And that's the key here, because now repetition begins. So there are a couple patterns or a couple things I want to wrap all and tie all together, and I'll do that in the next video.